Nobody talks about Europe when it comes to AI. They're all looking at Silicon Valley and Beijing. But while the hype was elsewhere, 3 German automakers quietly built something serious. But before we dive in, did you know that 65% of you listening and reading are not subscribed to our socials? Come on, guys, hit that follow button and collect our episodes on pods.media. Thanks, everyone.
It really is a completely different paradigm from what dominates our usual tech news cycle.
Yeah, and that is the exact premise of our deep dive today. We are pulling from a really revealing excerpt titled Automotive Intelligence, the German AI Revolution.
Right, from Unlocking the Future, issue 94.
Exactly. And our mission for you today is to basically uncover this hidden industrial revolution. We're trying to figure out how Germany's automotive giants and their foundational suppliers are taking AI out of the realm of those flashy screen-based tech demos
and embedding it into actual heavy industry.
Right. We're exploring why this massive kind of under-the-radar shift is fundamentally rewiring the global manufacturing economy. And honestly, why you should be paying very close attention to it.
What's fascinating here is the stark contrast in application. While the broader public is, captivated by AI chatbots generating marketing copy or making synthetic images.
The fun stuff, basically.
Right, the fun stuff. But these European organizations are quietly constructing physical and industrial AI. And they aren't just running isolated experiments.
No, they're really not.
They are deploying it at a scale that actively alters global supply chains. I mean, we are talking about the actual physical building blocks of the modern economy here.
I'm glad you brought up that idea of isolated experiments because I think the most common trap we fall into is thinking of AI as a standalone feature.
Like a prompt box on a screen.
Exactly. But when you look at Volkswagen's current strategy, it just completely shatters that assumption. Because true AI dominance, it isn't a feature you interact with. It's the invisible infrastructure powering the whole ecosystem behind the curtain.
Yes. The excerpt makes it explicitly clear. Volkswagen is not running pilots. They are running core infrastructure.
Which is a huge difference.
That distinction is critical to understand. A pilot program is essentially a sandbox. It's highly controlled, heavily monitored, and crucially, if a pilot fails...
the factory keeps making cars.
Exactly. It's low stakes. Infrastructure, on the other hand, is the foundational plumbing. It's the electrical grid.
So if it goes down, everything stops.
Right. If Volkswagen's AI infrastructure experiences an outage, the actual assembly lines grind to a halt. By elevating AI to the infrastructure level, they've inextricably linked their core revenue generation to these predictive models.
And the sheer volume of this integration is heavy. I mean, the data shows they have over 1,200 active AI applications running across the group globally.
Testing. Active.
And they've committed up to 1 billion euros to this by 2030. Now, spending 1 billion euros on software infrastructure when, Chinese EV competitors are aggressively undercutting them on price feels like a massive gamble.
It does until you look at the projections.
Right. Because the math they are projecting is wild. They expect 4 billion euros in operational savings by 2025 alone. And they're cutting vehicle development cycles by over a year. Okay, let's unpack this. 1,200 applications and a 4x return on investment in just a few years.
Yeah, it's staggering.
It's because Volkswagen isn't just buying off-the-shelf software. They're building a large industry model.
Right.
So instead of training an AI on Wikipedia articles to write poetry,
they are training it on vast multi-supplier data.
Right, covering everything from thermodynamics and welding to global logistics. Think of it less like a smart tool and more like a global air traffic controller.
I love that analogy.
It's like an AI that can spot a microchip supply chain delay in Taiwan and then autonomously adjust the sequencing of a paint shop in Wolfsburg so they don't run out of components mid-shift.
That air traffic controller analogy captures the mechanism perfectly. And to really grasp the financial gravity of cutting a vehicle development cycle by a full 12 months, you have to look at the capital intensity of the automotive sector.
It's not like building an app.
Not at all. Developing a new vehicle platform from scratch requires billions of dollars tied up in engineering, aerodynamics, crash simulations, tooling. Traditionally, that capital is locked up for years before a single car is ever sold.
Wow, just sitting there.
Exactly. So by shaving a year off that timeline using their large industry model, they simulate and optimize designs before physical prototypes are ever built. Volkswagen dramatically accelerates their time to revenue.
And they're doing this on their digital production platform, right?
Yes. which is a synchronized factory cloud they built in partnership with AWS. They aren't just speeding up one localized plant, they are pushing these optimizations across their global manufacturing footprint instantaneously.
Which creates a barrier to entry that legacy competitors just can't overcome with analog processing.
Precisely.
So Volkswagen has successfully turned AI into this invisible, omnipresent nervous system in the cloud. But that's purely back-end optimization. BMW is taking this technology in the exact opposite direction.
They are.
They aren't hiding the AI in a server farm. They are putting it inside physical bodies, walking around the factory floor.
Yes, BMW has distinguished itself by becoming the only European automotive manufacturer currently running humanoid robots in active daily production.
Here's where it gets really interesting. Because the moment anyone hears humanoid robot, our cultural conditioning immediately screams sci-fi gimmick.
Oh, absolutely.
And I have to push back on BMW's strategy here. Car factories have utilized highly efficient, single-purpose robotic arms for decades. We all know the footage of those massive orange arms spot welding a chassis in seconds.
Yeah, they're iconic.
So why on earth would BMW replace a specialized $50,000 robotic arm with a highly complex, phenomenally expensive humanoid robot just because it has two arms and legs? Isn't that just an engineering flex that hurts their margins?
It sounds totally counterintuitive until you look at the architecture of legacy manufacturing. Let's look at the mechanics of a factory. A massive percentage of global manufacturing happens in brownfield sites.
Meaning older factories.
Right. Factories that were built decades ago, designed entirely around human biomechanics. The staircases, the width of the aisles, the height of the assembly tables.
Their ergonomic reach required to pull apart from a bin.
Exactly. It is all scaled for a human body. So if BMW wants to fully automate a legacy assembly line using traditional, specialized robotic arms, they can't just bolt them to the floor.
They'd have to tear everything out.
They have to tear out the human-centric infrastructure, halt production for months, and rebuild the entire environment to suit the limitations of the robotic arm.
Wow.
A humanoid robot bypasses that massive capital expenditure entirely. It simply drops into the exact physical space previously occupied by a human worker.
That makes so much sense.
It walks up the same stairs, reaches into the same bins, and uses the same tools. The versatility justifies the upfront cost because it eliminates the need to redesign the factory.
That drastically shifts the financial equation. They aren't paying for a robot, they're paying to avoid a factory rebuild. And the data from BMW's Spartanburg plant in the US proves this isn't theoretical. They deployed a humanoid robot designated Figure 02. It worked 10-hour daily shifts, seamlessly navigating these human-centric workstations.
Just doing the work.
Yeah, during the pilot, it autonomously moved over 90,000 components, directly supporting the assembly of more than 30,000 BMW X3s.
That volume is definitive proof of concept, but Spartanburg was just the beginning. They are currently structuring a much more ambitious deployment at their Leipzig plant in Germany.
Oh, really? What's the timeline on that?
It's utilizing a different humanoid platform called Aeon, developed by Hexagon Robotics. The full pilot phase is slated for the summer of 2026.
Summer of 2026, okay.
And the operational focus is incredibly strategic, high-voltage battery assembly.
Of course.
Battery modules are heavy, the assembly requires millimeter precision, and the high-voltage environment carries inherent safety risks for human workers. It is the absolute perfect vector for advanced physical AI.
And to ensure this doesn't just remain a collection of, disjointed science projects, the excerpt highlights that BMW has officially established a center of competence for physical AI.
That institutionalization is the key takeaway there. Establishing a center of competence means BMW has moved past the discovery phase.
They're locking it in.
They are now actively writing the standardized operating procedures to scale autonomous humanoid deployments systematically across their entire global manufacturing network.
So if we look at the board right now, Volkswagen is dominating the invisible cloud infrastructure, and BMW is leading the charge on physical robotics on the floor.
Right.
But neither of those things directly touches the consumer. This logically brings us to Mercedes, because their strategy attempts to bridge the gap between how the car is built and how the car is experienced.
Yes. They are attacking both the manufacturing process and the consumer products simultaneously.
Let's look at the product side first. Their upcoming CLA model is engineered around MB.OS, running entirely on NVIDIA's full-stack drive software.
A powerhouse partnership.
Yeah, and for the user interface, they are deeply integrating Microsoft and Google AI. The analysis describes the vehicle not as a car, but as a software-defined platform.
I love that phrase.
Right. Instead of the old paradigm where a car's technology starts degrading the minute you drive it off the lot, this is an evolving hardware matrix. It's basically a smartphone on wheels.
That's a great way to put it.
It's designed to continuously receive over-the-air updates that optimize battery management, upgrade autonomous driving capabilities, and refine the interface over the entire lifespan of the vehicle.
If we connect this to the bigger picture, the brilliance of Mercedes' approach really lies in their restraint. Notice the partners involved. NVIDIA, Google, Microsoft.
The heavy hitters.
Exactly. The instinct for many legacy automakers was to try and build their own massive tech stacks from the ground up to maintain total control.
Which is incredibly expensive and slow.
Right. Mercedes recognized that attempting to out-engineer NVIDIA on silicon or out-train Google on large language models is a profound misallocation of resource.
They know what they're good at.
Instead, they're acting as the master orchestrator. They leverage the absolute best-in-class computational layers from their partners, but they maintain total proprietary control over MB.OS and the luxury integration.
And they're applying that same highly orchestrated approach back on the factory floor, too.
Yes, they are.
The excerpt notes Mercedes is rolling out digital twins alongside generative AI production systems. And a digital twin, it isn't just a 3D CAD model. It is a one-to-one, mathematically accurate virtual simulation of a physical factory.
It's basically a clone of reality.
Exactly. Before Mercedes physically moves a single robotic arm or alters a supply chain route in the real world, they run millions of permutations inside the digital twin.
To identify bottlenecks that a human planner could never foresee.
Right, so Volkswagen pushes the boundaries of scale, BMW pushes physical robotics, but Mercedes manages to stay fiercely competitive across both the digital and physical domains.
We've spent this entire time analyzing the OEMs, the consumer-facing brands.
Sure.
But there is a glaring omission in how the public understands automotive manufacturing.
Oh, what's that?
The reality is that the OEMs are largely integrators. The actual technological breakthroughs, the core puzzle pieces of this AI revolution, are being engineered by a layer of the industry that rarely makes the headlines.
The foundational suppliers.
Exactly.
If you want to know how the magic trick actually works, you have to look at the people building the props, the quiet arms dealers of the AI revolution.
That's spot on. If you want to comprehend the bedrock of the German AI revolution, you must examine the trajectory of suppliers like Bosch and ZF.
Bosch's strategy is particularly aggressive. The excerpt describes them as creating a horizontal AI layer. They're developing AI-driven cockpit systems, advanced motion control, and these deeply integrated by-wire technologies.
By-wire is a massive shift.
It really is. It's a perfect example of how radical this is. We aren't talking about power steering here. By-wire means they're physically removing the mechanical steering column that connects the steering wheel to the tires.
Which sounds terrifying to some people.
Right. Instead, the steering wheel just sends electronic data to an AI. That AI calculates the optimal angle, traction, and resistance in milliseconds, and then commands electronic actuators on the wheels to turn.
It's all digital.
And Bosch isn't just building this for one brand. They're building the fundamental mechanics of the future, packaged and ready to sell to anyone.
That horizontal scalability is the ultimate power play. Bosch doesn't care who wins the market share war between BMW, Volkswagen, or Mercedes.
Because they're in all of them.
Exactly, because Bosch's AI layer is embedded in all of them. And ZF is executing a very similar strategy. They've partnered with Qualcomm to build heavily scalable ADS, Advanced Driver Assistance Systems.
Right, and ADS isn't just lane keep assist anymore. It is real-time spatial computing. It's processing massive amounts of sensor data to map the vehicle's surroundings dynamically.
Which takes an incredible amount of processing power.
It does. And ZF is packaging that computational architecture so it can be deployed across wildly different vehicle platforms. They're essentially building the operating system for physical movement.
Which brings us to a highly complex friction point. We have established this incredibly robust ecosystem. AWS factory clouds, humanoid robots, digital twins, and horizontal AI layers.
Yeah, the tech is there.
But technology does not exist in a vacuum. It has to survive contact with reality. And specifically, it has to survive contact with the European regulatory environment and a famously demanding consumer base.
And the market numbers dictate that they have to get this right. The European automotive AI market is currently valued at $6.37 billion as of 2025.
That's a massive market.
Yeah, but the projection is a staggering leap to $19.59 billion by 2034. And out of that massive European pie, Germany commands a dominant 28.7% share.
Huge stakes.
But as the analysis points out, European consumers harbor a deep, culturally ingrained skepticism toward autonomous driving, far more so than consumers in the US or China.
That skepticism fundamentally alters the engineering mandate. Because the consumer trust is low and the regulatory oversight is intensely high, German companies cannot adopt the Silicon Valley ethos of pushing beta software to live users and patching the bugs later.
You can't just fix it in post when you're driving on the Autobahn.
Exactly. The regulatory compliance must be mathematically proven and baked into the absolute lowest layers of the AI architecture before it ever touches a public road.
So what does this all mean for you, the listener? Does this intense regulatory burden act as an anchor, kind of dragging down their ability to compete globally?
It creates a fascinating paradox, actually. In the immediate short term, yes, the stringent European regulations and deep consumer skepticism act as a massive constraint on their speed to market.
Right, they have to move slower.
But if we project 5 years into the future, that constraint morphs into an impenetrable competitive advantage.
Oh, interesting. How so?
By forcing these companies to engineer incredibly safe, transparent, and highly compliant AI systems from day one, they are future-proofing their technology. I see.
When the inevitable wave of severe AI regulation crashes down on the rest of the global market, the Silicon Valley and Chinese firms will have to painfully reverse engineer compliance into their existing platforms.
While the German ecosystem will already have that trust fundamentally integrated.
Exactly.
They are absorbing the friction up front to own the future. Let's synthesize all of this. The excerpt provides a great summary of the landscape, calling it the bros take.
Yeah, I like that section.
It clarifies that looking for a singular winner is just the wrong framework. Volkswagen secures its dominance through massive scale and cloud-based infrastructure. BMW secures its future through aggressive physical innovation and humanoid deployment on the assembly line.
And Mercedes wins through holistic integration.
Right, creating a seamless AI loop from the factory floor simulation all the way to the driver's interface.
The real narrative to pull from these sources is a total reframing of global tech momentum. There is a pervasive stereotype that Europe is lethargic, overly bureaucratic, and hopelessly outpaced by the innovation hubs in California and Beijing. Right, the old dinosaur trope.
Exactly. But when you look at the highly complex, high-stakes domain of industrial and automotive AI, the German ecosystem is executing a revolution with a level of depth and seriousness that the broader tech media has completely missed.
It really forces you to reevaluate our cultural obsession with software disruption. We have been conditioned to believe that the move fast and break things philosophy is the only legitimate way to win a technological arms race.
It's practically dogma at this point.
It is. But think about the reality of the product. When you are stepping into a 2-ton metal box, hurtling down a crowded highway at 70 miles an hour, wouldn't you strongly prefer that the AI calculating your braking distance was built by engineers culturally obsessed with rigid compliance, redundancy, and absolute safety?
No, I would.
Maybe the next decade of AI dominance isn't going to be awarded to whoever builds it the fastest, but to whoever figures out how to build it the safest.
That is a critical paradigm shift to consider as this technology matures.
It really is. Thank you all so much for joining us on this deep dive. Keep questioning the world around you, and we'll catch you on the next one.